Aloha, everybody. All right, so the purpose of this video is to go through this worksheet and get you set up for the other two worksheets that we'll be handing out as well with solving 1- and 2-step equations. So I always like to do this at the start of class. This is some major objectives that we do in class, and these are the two most important ones that we will see a lot. So I'll have you guys fill in notes as we kind of go through this here. The first thing that we do that I'd like to remind you guys is simplifying. And the things that we simplify are called expressions. So write that up in your notes up there, simplify expressions. The goal of simplifying is to combine like terms and do any sort of reduction that you need to. So you would reduce each term as well. Let me slide that over. So here's an example. So at any time you can pause this video so that you can write this down and copy it in here. So here's an example that we want you to simplify. So we got 5x minus 8x plus 1/2 plus 5a. So combining like terms is terms that have the same variable with the same exponents. So if you look at these guys, 5x and 8x, these guys are the same because they have the same variable x, and the exponent on them is both a 1. So these guys are combinable. So this is like you look in your pocket and you got $5, and you look over here and, oh, this is a -8. This is like you owe somebody $8. Well, if you have $5 and you pay them that $5, you're still going to be in debt by $3. So 5 minus 8 balances out to a -3. And both of these are referring to an x. So when you just have the variable sitting there, when you're adding and subtracting, the number in front tells you how many of those things you have. So 5x's, take away 8x's, you have -3x's left. Over here, these guys are also like terms because they both lack a variable. So they don't have a variable at all. So they're kind of sharing the same variable of a non-variable. And this is a refresher of a long time ago adding and subtracting fractions. In order to add fractions, you need to get a common denominator. So you don't need an LCD, but it's nice to have the lowest one so that you have less reduction later on in life, if possible. So in order to add these fractions, we're going to get a common denominator, looking for like the lowest common multiple between a 2 and an 8. So what's the smallest number that both of these numbers will go into? Turns out that it's an 8 here. So this one is already has a denominator of an 8. We're going to have to turn this one into a denominator of an 8, and we can do that by multiplying the bottom by 4. And what we want you to do is to perform legit math moves. If you're going to multiply the bottom of a single fraction by 4, you have to multiply the top of that fraction by 4. And how you multiply fractions is straight across. So if I multiply straight across, 4 times 1 is 4, and 4 times 2 is 8. So 1/2 and 4/8, they're the same value. They're the same value. Like if you were to decimalize them, they're both 0.5. And we can multiply this number by 4 over 4 because that's essentially the same thing as like multiplying by 1. 4 divided by 4 is 1. And multiplying any number by 1 doesn't change the value, just allows us to rewrite it in a different way. So that's okay. So we're looking at like 4/8 plus 5/8. That's about 9/8. Now, if you want to, you could rewrite this as like 1 and 1/8 if you wanted to. 8 goes into 9 once with 1 left over. That would be fine as well. And whenever you're simplifying, you're following PEMDAS. So we'll review that in the next slide. So this gets paired up, and this is buddy-buddy with the other one, which is solving. The thing that we solve are called equations. Now the main difference between an expression and an equation is an equation has an equal sign. So that's how you can tell that these things are different. You still follow PEMDAS along the way, but it gets you do a little bit different steps. So you're still working and simplifying each side, and you're just trying to undo the math, and what you do one side, you have to do the other. So coming back up here, the goal is to find value or values for the variable or variables that satisfies the equation. Satisfying the equation means when you plug in the values, you get a true statement. So like I'm going to find a value for x down there that when I plug it in and check it out, I'm going to get something times 3 plus 4, that's going to be 25. Another way you could put this is you are trying to get x alone by itself. You're trying to isolate your variable. So when you see something like this, if we're trying to get x alone, we want to undo everything around it. There's only two things that's going on. One, x is being multiplied by 3, and two, x is being, or has 4 being added to it. So typically when you follow your PEMDAS, you can kind of work backwards. So really we'd want to get this thing out of the way first. So the way that you undo an addition by 4 is a subtraction by 4. And if you're going to subtract 4 on the left-hand side, you have to subtract 4 on the right-hand side. Now the sides are determined by the equal sign. The equal sign is what gives you your left and right-hand side. Left side, right-hand side. So some people will draw a line that goes through it like that. So when I say what you do one side, you do the other, it's talking about the equal sign side, the sides of the equal sign. So here, positive 4 minus 4, that will cancel out to be 0. So the only thing left over here is a 3x. And on the right-hand side, 25 minus 4 is about 21. And there's the next step. So now here you can kind of think 3 times what will get you to 21. So again, you have to, we should remember that when a variable is sitting next to a number, they're assumed to be multiplied. So how do you undo multiplication? You can undo multiplication with division. If you're going to divide the left-hand side by 3, you got to divide the right-hand side by 3. Now this turns out really nice because 3 divided by 3 is 1. Oh my god, we've seen that before. And on the right-hand side, 21 divided by 3 is about 7. So 7 is an answer that we'll get. It's our solution that works and satisfies the equation, because if I replace x with 7, 3 times 7 is 21. 21 plus 4 is 25. Yippee-ki-yay. All right, so here is your quick review. So if you want to flip the page over, you can write this on the back side. So this is just your order of operations, PEMDAS, parentheses. You're going to start with those first, and parentheses work inner to outer. So if you have a whole bunch of nested parentheses, you're going to start with the inside and then slowly work your way outside. Exponents, there's only 2 things you need to know about exponents, and we'll get to that when we get to that. But exponents would come next. After that, multiplication division is paired up together left to right. The D also stands for drop parentheses. Some teachers say that, I'm one of them, some teachers don't. So it kind of really depends on the scenario, but we can talk it out when we see those scenarios. And then lastly, we'll be working on addition, subtraction, and again, that's together left to right. So what we'd like to do is to work on these 2 worksheets that we handed out, and we want you to stick just on the left-hand side. So start working on all of the odd problems. So there's a couple of them here that I want to go through and just do so that to give you guys some more practice with these, and you can write these down in your notes. And then after that, we'll kind of be walking around and checking out how you guys are doing on here. So we're going to start actually number 6 here. So your goal is to solve these equations. So again, we solve them by, we're trying to find the solutions. So we're trying to find the values for the variable that when we plug them in will make a true statement. And we're trying to isolate our x, and we're going to undo everything that's around it. So right now, the only thing that's by this x right here is a minus 7. So we can undo a minus 7 with a plus 7 on both sides. And again, if you want to draw that vertical line that goes through here, that's perfectly fine too. Sorry for all those loud clicks. All right, so then you should get your answer of 20. And if you want to go back and check it out, you can. If I do 20 minus 7, I get 13. Yippee-ki-yay. Now this one I want to do because it's a little bit different. So here 15 is being added to b. So if you want to undo the addition of 15, you can do that with the subtraction by 15. But normally you're going to be looking at the sign in front of it. So in front of this, if there is no sign, it's assumed to be positive. If it was negative, you'd see a negative sign in it. Kind of like here's a negative 56 down there. So since this is a plus 15, we're going to undo it with a subtraction by 15. And if you're going to subtract 15 on the left, you got to subtract 15 on the right. 23 minus 15, that's about 8. And sure enough, if you go back and check your answer, 15 plus 8 is 23. Down here, again, if you have a variable sit next to a number, they're assumed to be multiplied. So we would undo a multiplication by 8 with a division by 8. Ooh, and what is 104 negative divided by 8? So you can pull out your calculator. Hope you guys bought a TI 30X2S by now. And you should get a value of negative 13. All right, so there's a start for some of those problems. So work on the left-hand side doing the odd ones. Raise your hand if you have any questions. Otherwise, we'll work on it and we'll help you out. Thank you.